Grade 5, MX18, Lesson 2 and 8/10 from the Addition and Subtraction with Decimal unit. Some decimal humor for you there. Hello students and families. This video resource can be viewed as a reminder of learning that happened in the classroom, a review of learning that was missed during an absence, a preview of new learning. Remember, this video cannot replace the math conversations and group learning that takes place in the classroom. If you have questions or would like additional practice, please speak to your teacher. Additional resources are available on the Think Central website. Ask your classroom teacher about how to access this site from home. Our student-friendly learning goal for today: I can estimate and solve decimal addition and subtraction problems. Here are some of the Tier 3 vocabulary words that will be used in this lesson. Keep in mind that these are not the entire list of vocabulary words for this lesson. Estimating is a strategy that we can also use with decimals. Rounding a decimal up or down can help us see if our answers make sense. On the number line above, 1 and 62 hundredths is shown. To make it easier for us to estimate, should we round this up to 1 and 7/10 or down to 1 and 6/10? It makes the most sense to round down to 1 and 6/10. Let's try the same practice with the decimal 1 and 68 hundredths. Should we round this up to 1 and 7/10 or down to 1 and 6/10? It makes the most sense to round up to 1 and 7/10. Let's see what rounding looks like with a decimal addition problem. Looking at the first number, 4 and 672 thousandths, which place value would you round to? For this problem, it makes the most sense to round to the nearest tenths place. We would round up to 4 and 7/10. Looking at the second number, 6 and 337 thousandths, which place value would you round to? Since we rounded the first number to the tenths place, we should do the same for this number. We would round down to 6 and 3/10. Now we can estimate an answer. We get 11. Using our traditional method to solve, we align the two numbers. 7 thousandths plus 2 thousandths equals 9 thousandths. 7 hundredths plus 3 hundredths equals 1/10. We regroup the tenth. 1/10 plus 6/10 plus 3/10 equal 1 whole. We regroup the whole. 1 plus 4 plus 6 is 11. We can see that the actual answer is quite close to our estimate. Let's try to estimate a subtraction problem with decimals. In some problems, it may be best to round to the nearest whole. Here, 4 and 11 hundredths could be rounded down to the whole number 4. 3 and 28 hundredths can be rounded down to 3. A reasonable estimate is around 1. If we actually solve for the real answer, we see that 83 hundredths is close to our estimate. Just like with estimating fraction sums and differences, estimating decimal answers really depend on the context of the question. Are there times when you want to be fairly accurate with your estimate? Yes. Think about spending money that you do not have. Are there other times when an estimation can be less exact? Yes. Think about the difference between first and last place at a track race. Here is problem number 5 from the homework. The directions say to round to the nearest tenth. Looking at the hundredths place value as a guide, 8 hundredths is closer to 3 tenths than it is to 2 tenths. It makes the most sense to round up to 5 3 tenths. Here is a reminder of the learning target for today. As always, if you have additional questions or if you would like more practice, please talk to your teacher when you return to the classroom. As we continue to build this resource for students and families, any feedback that you have would be appreciated. Feel free to email with any suggestions that you may have.